Plotting points in polar coordinates. We've seen in our discussion of vectors that describing where a point is in two-dimensional space as the terminal point of a vector, we can either talk about its components, its x and y coordinates, or we can talk about its magnitude and direction. The idea of polar coordinates is to use the magnitude and direction to define the point. So if we are looking in a coordinate plane and we have some point, instead of calling this thing xy, we are instead going to name this thing as r theta. And the idea here is we take a vector from the origin to that point. We find the magnitude, which we're going to call r, and the direction, which we will still call theta, of that vector, and we use those as the ordered pair that describes this point. The reason that we call the magnitude r is that if you look at every point with the same magnitude, it defines a circle. And when you're plotting things in polar coordinates, you're really thinking about concentric circles. Right. If you squint and tilt your head a little bit, these look like perfect circles that are all centered at the origin. So we have r equals 1, r equals 2, and r equals 3. We find our angle in standard position. Let's say, for example, we want to plot 3 pi over 6. Well, pi over 6 is going to be something like this first line. So I'm just cutting each of these quadrants in 3. That was really bad. Let's try that one again. Cutting each of these quadrants in 3 so that I get 30, 60, 90, which is pi over 6, pi over 3, pi over 2. And then count out 3 concentric circles to get a point right there. I can also look at points that are defined with negative radius, which is a little bit goofy. So if I had negative 2 pi over 6, then I would still be on the same pi over 6 line, but instead of counting out in the direction of pi over 6, I count away and get a point something like that. I could also choose, instead of counting an angle in a positive direction, I could count the angle in the negative direction. And maybe I want to plot something like 2 negative pi over 4. Right? Pi over 4 cuts the quadrant in half. Right? That's 45 degrees, halfway between 0 and 90. So you get a point, maybe something kind of like that one. Right? But the big idea of polar coordinates is just like we can take vectors and switch between component form and magnitude and direction. The component form has x and y, which are the x and y coordinates of a point. The polar form has, the magnitude and direction of a vector describes a line going to the same point, and polar form takes that magnitude and direction and says, okay, this is now the ordered pair we are going to be using. So polar coordinates are really just vectors and deciding that magnitude and direction makes more sense.